3, right? We covered page 1 on Wednesday, right? Talked about the slope of a line. There are 2 forms for the equation of a line: the point slope equation of a line and the slope intercept equation of a line. What you see in mathematics most frequently is the slope intercept form of the line. And then we worked examples 1 and 2. So on page 2, we're going to talk about parallel and perpendicular lines. 2 non-vertical lines with slopes M1 and M2 are parallel if and only if their slopes are equal. Okay? So 2 parallel lines have equal slopes. 2 lines with non-zero slopes, M1 and M2, are perpendicular if and only if their product is equal to -1. Okay? So for perpendicular lines, we have M1 times M2 is equal to -1. If I divide both sides of this equation by M2, I have M1 is equal to the negative reciprocal of M2. And if I divide both sides of this equation by M1, I have M2 is equal to the negative reciprocal of M1. Okay? It's often easier for students to remember these 2 ways of recognize whether 2 lines are perpendicular or not, right? The slope of one line is the negative reciprocal of the other line, as opposed to the product of slopes being -1. Okay. All right, so in example 3, it says find the equation for the line passing through the point -4, 1 that is parallel to the line 5x minus 2y is equal to 3. So our parallel line is going to pass through the point -4, 1. Right? -4 is the x-intercept, 1 is the y-intercept, and it's parallel to the line 5x minus 2y is equal to 3. So this is the equation of a line, right? So this is the given line written in general form, okay? Well, we got to find the slope of the given line so we know what the slope of the line parallel to it is, okay? That passes through this point. So we got to solve for y. And so one approach is first to move the 5x to the right-hand side via subtraction. Minus 2y is equal to minus 5x plus 3. And now we divide both sides by minus 2y, or not minus 2y, minus 2 to isolate the y. On the left-hand side, okay? So the minus 2's cancel, and we're left with y. On the left. Now, riddle me this, ladies and gentlemen. Fraction bars are like division symbols. Does division undo addition? No. So we got to divide each of those terms by minus 2. -5 divided by -2, right? Negative or negatives half is positive. So we have plus 5/2 times x, right? I can bring the x out to the right side of the fraction. And then 3 divided by -2 is the same as minus 3 halves. So the slope of the given line is 5 halves. That's the slope of the given line. Okay. Now we got to find the equation of the line that's parallel to this line that passes through this point. And so we can use point slope form to write the equation of the line. Y minus y1 is equal to m times x minus x1. x1 is equal to negative 4, y1 is equal to 1. And so we have y minus 1 is equal to the slope 5 halves times x minus the negative 4. Well, minus a negative 4 is the same as plus 4. So this is the equation of the line in point slope form. That is parallel to the given line. Now, if we want to write it in slope-intercept form, we got to solve for y, right? So we distribute the 5 halves inside the parentheses on the right-hand side. We have 5 halves x plus 4 times 5 halves, which is 10. All I did was distribute 5 halves inside the parentheses. And now I add 1 to both sides. And I get y is equal to 5 halves x plus 11. And that is the slope intercept form. For the equation of the line that's parallel to the original line. Okay. Any questions on that? So let's look at example 4. Find the equation of the line perpendicular to this given line that passes through the point 3 minus 2. Write your answer in slope-intercept form. Now we're told specifically how to write the answer. So the given line is 3x minus 1/2 y plus 7 is equal to 0. Right? That's the given line. And the line that's perpendicular to it passes through the point 3 minus 2. 3 is the x coordinate, minus 2 is the y coordinate. So we got to find the slope of the given line, right? So to do that, we got to solve for y. So we subtract 7 from both sides. We have 3x minus 1/2 y is equal to negative 7. And now we can subtract 3x from both sides. We have minus 1/2 times y is equal to minus 3x minus 7. Now you could divide both sides by minus 1/2, but that makes life difficult. Minus 2 times minus 1/2 is 1. Okay. So we'll do minus 2 times minus 1/2 y is equal to minus 2 times minus 3x minus 7. Minus 2 times minus 1/2 is 1. So we just end up with y on the left side. And now we got to distribute the minus 2 inside the parentheses. And minus 2 times minus 3x is 6x. And minus 2 times minus 7 is 14. So the slope of the given line, I'm going to put a little perpendicular there in the subscript, right? Because the two lines are not going to have the same slope. Right? So the slope of the given line is equal to 6. So the slope of the line that's perpendicular to it is the negative reciprocal of 6. So m is equal to the negative reciprocal of 6, which is minus 1/6. So that is the slope of the line perpendicular to the given line. Okay. So now we know the slope of the perpendicular line, and we know the point it passes through. So we can write the equation for that line in point slope form. So y minus y1 is equal to m times x minus x1. Y minus y1 is y minus a negative 2 in this case. M is minus 1/6, and x1 is 3. Well, y minus a negative 2 is the same as y plus 2. And now when you distribute the minus 1/6 inside the parentheses, you have minus 1/6 times x. And minus 1/6 times minus 3 is plus 1/2. And now you subtract 2 from both sides. You know, y is equal to minus 1/6 x plus 1/2 minus 2. And 1/2 minus 2 simplifies to minus 3/2. So we have y is equal to minus 1/6 x minus 3/2. So this is the equation of the perpendicular line in slope intercept form. Any questions on that? if you flip over, we're going to do a word problem. Biologists have noticed that the chirping rate of crickets of certain species is related to temperature, and the relationship appears to be very nearly linear. A cricket produces 113 chirps per minute at 70 degrees Fahrenheit, and 163 chirps per minute at 80 degrees Fahrenheit. So the temperature seems to drive the number of chirps per minute. Okay. Find a linear equation that models the temperature T as a function of the number of chirps per minute. Now that seems backwards, doesn't it? Temperature determines the number of chirps per minute, but we're going to use chirps per minute to estimate the temperature, calculate temperature. Okay. So we're sort of going in reverse. Okay. So find a linear equation that models the temperature as a function of the number of chirps per minute. Yeah. Okay. So let's define our variables. We'll let T stand for temperature, and it is a function of N, right? The number of chirps per minute. So in this problem, N is the input variable, or independent variable, and T is the output variable, or dependent variable. Okay. And so our ordered pairs are N, T. So when the crickets is chirping at 113 chirps per minute, the temperature is 70. And when they're chirping 163 chirps per minute, the temperature is 80 degrees Fahrenheit. So those are our 2 points. With those 2 points, we can calculate the slope of the line through those 2 points, right? And get the equation of the line. And then we'll have what's called the linear function for this problem. Okay. So the slope M through those 2 points, change in y over change in x, change in y is 80 minus 70, and change in x is 163 minus 113, which simplifies to 10 over 50, which simplifies to 1/5. So the slope M is equal to 1/5. Now we can use point slope form to come up with the equation. Is T a function of N, right? So we can use either of these points to write the equation in point slope form. I'm going to use the first equation. Okay? For the first point, we could use the second point. Okay? So T is the dependent variable. So we have T minus 70. And that's equal to the slope M, 1/5, times the dependent variable N, which replaces X, and then minus 113. So that is our equation, right, in point slope form. But now we got to simplify. Okay. So we have t minus 70 is equal to 1/5 n minus 113 divided by 5. Okay. Minus 113 fifths. And now we add 70 to both sides. And we have t is equal to 1/5 n. And then when we add 70, well, 70 is the same as 350 fifths, right? 350 divided by 5 is 70. And so t is equal to 1/5 n, and 350 minus 113 is 237. Well, with word problems, typically we don't like decimals in math, right? We like improper fractions instead of decimals. But with word problems, we often use decimals, right? Because it makes more sense. Like if you take physics, right, you work a lot with decimals, not improper fractions. So using 1/5 is the same as 0.2 as a decimal, and 237 divided by 5 is the same as 47.4. So that is our model in slope-intercept form. So that's A. Okay. That's our linear equation that models the temperature T as the number of chirps per minute. In B, it says if the crickets are chirping at 120 chirps per minute, estimate temperature. You may get an answer. We know what that answer is? So in B, we just put in 120 in for n. We have T is equal to 0.2 times 120 plus 47.4. Right, we're out in the woods. We want to know what the temperature is. Right. We don't have a temperature gauge, but we count the number of chirps per minute. With crickets, they're chirping at 120 chirps per minute. We plug into our equation and we estimate the temperature to be 71.4 degrees Fahrenheit. Any questions on that? Nada? Okay. All right, let's take a look at example 6. The manager of a furniture factory finds that it costs $2,220 to manufacture 100 chairs in one day and $4,800 to manufacture 300 chairs in one day. Assuming that the relationship between cost and the number of chairs produced is linear, right? That's key. It's linear, right? Because this section is all about linear functions. Find a function that expresses the cost of the chairs as a function of the number of chairs produced. Okay. So we got to define what X is, right? And students will ask me, well, how do you know which one is X and which one is Y? Okay. Well, when we write that, right, we're saying Y is a function of X, right? Y is a function of x, okay? Well, look at this last sentence, okay? Express the cost of the chairs as a function of the number of chairs produced. Right, so think of it as y as a function of x. What's x? Number of chairs produced. Okay? So you just replace the words with y as a function of x, and now you know what x and y are. Okay. So x is equal to number of chairs produced. And in place of y, right, we're going to come up with a function name as a function of x. And so we have, I'm going to use c for cost. And so instead of f of x, we're using c of x. C is for cost. And so c of x is the cost of x chairs produced. So y equals c of x in this case, instead of f of x. Okay. All right. So x is the number of chairs produced. So when we produce 100 chairs, the cost is $2,220, right? So that's 1 point in coordinate plane, right? The x coordinate is 100, the y coordinate is 2,220. When we produce 300 chairs in a day, the cost is $4,800. And now to get our cost function, right, as a function of x, the number of chairs produced, calculate the slope between these two lines, between these 2 points, right, the slope of the line that goes through these 2 points, and then write the equation, right, slope-intercept form, right, or point-slope form. Okay. So the slope of the line to those 2 points, change in y over change in x, rise over run, 4,800 minus 2,220, and change in x, 300 minus 100. So the numerator simplifies to 2,580, denominator to 200, and since this is a word problem, we'll use the decimal, right? 12.9. So that's the slope of the line through these 2 points, okay? So to write the linear function, remember the linear function is c of x equals mx plus b, right from the top of page 1. We know m, we got to find b, right? So we got to use one of these points for x and y. Okay? Doesn't matter which one you use, you'll get the same function, the same equation of the line. And so I use the first point. Okay? And so 100 is the x coordinate, 2,220 is the y coordinate. And so I put 2,220 in for y. M is 12.9. X is 100. And then we got to calculate the y-intercept b. Okay. Well, b is equal to 2,220 minus 1,290, right? 12.9 times 100 is 1,290. Then I subtract it from 2,220 to get B. And B is equal to 930. So, the equation of the line that passes through those 2 points is y equals 12.9 times x plus 930. But we want a linear function, so we replace y with c of x, cost of x chairs produced. Okay. So we have c of x is equal to 12.9 times x plus 930. So this is our cost function, right? That expresses the cost of the chairs as a function of the number of chairs produced. Any questions on A? Okay, in B, it says using this function, find the factory's fixed cost. That is, the cost incurred when the number of chairs produced is 0. Well, that is when x equals 0, right? So this turns out to be just the y-intercept, right? So you put in 0 for x, right? This is the y-intercept, 930. Okay. So C of 0 is equal to 12.9 times 0 plus $930. And so this is just equal to, right, C of 0 is equal to $930. That's the fixed cost, right? That's the cost that the company pays when they don't build a single chair. It's got to be paid anyway, because rent got to be paid on the building, things of that nature. All right. So any questions on that example? Okay. All right, let's take a look at number 7. Then you'll have everything you need to successfully complete the web-assigned homework. Write an equation of a line that passes through the point 1 minus 2 and is perpendicular to the line that passes through the points 4 minus 5 and minus 3, 1. All right. So the slope of the given line, which I'm putting this little perpendicular symbol down there, okay, is equal to, remember the slope of the given line passes through the points 4 minus 5 and minus 3, 1. So the slope of the given line is change in y over change in x, right? Rise over run. And so I wrote change in y, it's minus 5 minus 1. Then change in x is 4 minus a negative 3. Well, minus 5 minus 1 is negative 6. And 4 minus a negative 3 is plus 7, right? Minus a negative is the same as plus a positive. And so the slope of the given line is minus 6/7. Okay. Well, the slope of the line that's perpendicular to this one is the negative reciprocal of minus 6/7, right? So the negative of negative is positive, and the reciprocal of 6/7 is 7 over 6. So the slope of the perpendicular line is 7/6. So now we can write the equation of the perpendicular line in point slope form, okay? And remember, the perpendicular line passes through the point 1 minus 2. So 1 is our x1, minus 2 is our y1. So the equation is y minus y1 is equal to m times x minus x1. Y1 is negative 2. M is 7/6. And x1 is 1. Well, minus a negative is positive. So we have y plus 2 is equal to 7/6 times x minus 1. So that's the equation of the perpendicular line in point slope form. And now to get it in slope intercept form, we distribute the 7/6 inside the parentheses and then subtract 2 from both sides. So when we distribute the 7/6 inside parentheses, we have 7/6 times x minus 7/6. Now you guys subtract 2 from both sides. We have y is equal to 7/6x minus 7/6 minus 2. Well, 2 is the same as 12/6, right? 12/6 is the same as 2. So subtracting 12/6 from 7/6 is minus 19/6. So y is equal to 7/6x minus 19/6. That is the equation of the perpendicular line in slope intercept form. Ladies and gentlemen, you have everything you need to successfully complete the website. Now, I printed out 2.4 this morning, okay? So I'm going to give you these now, okay? So you can look them over the weekend if you choose. Some quadratic functions, or at least I won't have to carry them around all week. All right, so let's take attendance and get a jump on the weekend.